Welcome to another video where we will be factoring quadratic equations in order to determine the roots. But unlike the previous video, we will not restrict ourselves in solving quadratic equations with a, or the leading coefficient, or the coefficient of x squared equal to 1. So we will factor quadratic equations no matter what the value of the leading coefficient. Of course, except 0, because when 0 is the numerical coefficient of x squared, that will become a linear equation. Okay? So remember from last time, when we have x squared minus 4x is equal to 0, we want to factor it. We want to split this um, quadratic expression into its factors. Since both of them, both x squared and negative 4x, have a common factor of x, we can split it as x times x minus 4. Okay, so we can express this as x times x minus 4 is equal to 0. And now what? In order to determine the roots, now we have factored it already. We remember that when we are given two numbers, so, m and n, if we multiply them together, m times n is equal to 0, that means at least one of them must be 0. That is, m is equal to 0 or n is equal to 0. So similar idea happens here, since x is multiplied to x minus 4 and this is equal to 0. That means either x is equal to 0 or x minus 4 is equal to 0, which means x is equal to 0 or x is equal to, 4. So these are the values of the possible values, or the roots of the quadratic equation x squared minus 4x equals 0. So when we substitute 0, let's see, we can have a checking here in order to see if we are correct. So when we substitute 0, we will get 0 squared minus 4 times 0, which will be equal to 0, right? Another one, when we substitute 4, we will get 4 squared, which is 16. 4 times minus 4 times 4, which is equal to 0. So this is 16 minus 16, which is equal to 0. So we determined the roots of this equation. So how about for x squared minus 5x is equal to 0? So in this case, both of them also have x. So we can have factor out x. So x times 4x minus 5, okay, equals 0. And since they are multiplied together, we already factored them out. We equate each factor to 0. So x is equal to 0, or 4x minus 5 is equal to 0. And we treat them as separate equations. So we can have x is equal to 0. This is already a root. Or for x minus 5 is equal to 0. What is the value of x here? For x is equal to 5. So, okay, and in order to find the value of x, we can divide both sides by 4, and we will get x is equal to 5 over 4. And these two are the roots of this quadratic equations. Okay? So remember this, this concept of getting the greatest common factor in two terms will be useful later on when we will be factoring trinomials. Okay, now when we want to factor 2x squared plus 7x plus 6 is equal to 0, now there's a problem. We can't do whatever we have done earlier, where on the previous example where each term has a common factor. For these types of examples, in order to factor a quadratic equation of ax squared plus bx plus c, determine ac and b. So our a is the factor of x squared, so a is equal to 2, and c is equal to 6. So our ac here is equal to 12. 2 times 6, right? And b is the coefficient of 7, So, I'm sorry, coefficient of x, which is 7. Okay, so step 2. Okay, let's determine the factors of 12. Before step 2, still on step 1. Let's determine the factors of 12, where if we add them, the result must be b, which is 7. Okay, what are the factors of 12 that when we add them, that is equal to 7? The factors of 12, let's write it here. Factors of 12, we can have 12 and 1, right? But if we add them, we will have 13, right? We can have 6 and 2, but when we add them, we will get 8, and we have 4 and 3. So if we add them, we will get 7. So these two are the factors that we want. Of course, there are also negative factors. For example, negative 12 and negative 1. That's also possible. But again, their sum is negative 30. So these two factors, 4 and 3, factors of 12 are the factors that we want. So step 2 is we express b, okay, as this factor. So we can express this as 2x squared, this quadratic equation, plus 4x plus 3x plus 6 equals 0. Okay, so that's how we do it. Okay, we express 7 as 4x and 3x. Okay, if we simplify, we'll just get back to the original equation. So we want to express this equation as such as this, right? Then next step is group the first two terms together and the last two terms together. So we'll group this to x squared and 4x and group 3x plus 6. And the step 4, for each group, factor out a GCF from each group of binomial. Okay, so like the previous example where there are only two terms, we will find the greatest common factor for each of these groups of binomials. So for example here, 2x squared plus 4x, both of them have common factors of 2x, right? So we can factor out 2x, and what will be retained? X plus 2. And here, in the second group, we can factor out 3, and what will be retained? We can retain x plus 2. Okay. Okay, let's just pause here. If you find it difficult, okay, so 2x squared plus 4x, we can see this, we can express this as 2 times x. And here, 4x, we can express it as 2 times 2 times x. Okay, we can factor out they have both 2x and they're common factors, so we can factor out 2x. And what will be left? In the first term, x is what will be left, and in the second term is just 2, so x plus 2. And that is how we get 2x times x plus 2. Okay, now we have factor the GCF for each group of binomial. We want to factor out the common binomial. How do we factor out the common binomial? Well, both of them, okay, for each term here, both of them has a factor of x plus 2. So we can factor out x plus 2, and what will be left is 2x plus 3. And this is equal to 0. Okay, and we have factored the quadratic expression. However, what we want to do is to determine the roots. This is just a factoring part. So if we want to determine the roots, remember, so let's just erase this first. Remember that in order to determine the roots, equate each factor to 0. So each factor here, x plus 2 is equal to 0, or 2x plus 3 is equal to 0. So that means x is equal to negative 2, or 2x is equal to negative 3, and x, we divide both sides by 2, x is equal to negative 3 halves. So this 2, x is equal to negative 2, and x is equal to negative 3 halves. These two are the roots of the quadratic equation. Next example, about 4x squared plus 4x minus 3. Again, with the same method, we want to determine AC and B, right? AC here is, where our A here is 4. Yeah, right 4. However, our C here is negative 3. So don't forget the negative sign, negative 3. Okay, and so our AC here is negative 12. Our B here is the numerical coefficient of x is 4. So what are the factors of negative 12? Factors of negative 12 that when we add them together, the sum must be positive 4. Okay, we can again enumerate each of them, right? 12 and, well, we can have 12, negative 12 and 1, but that is negative 11. When we add them, we can reverse the signs, 12 and negative 1, but that is positive 11, right? But we can also have 6 and negative 2, right? And this pair of factors of negative 12 is when their sum is positive 4. So we can express bx as 6x minus 2x. So let's write it as like that. This. So we can write 4x squared plus 6x minus 2x minus 3 equals 0. So 6x minus 2x, we rewrite 4x as 6x minus 2x. And now we can group the first two terms together. 4x squared plus 6x. What are their common factors? Again, you can see here. You can see here 4x in the lower right. Let's make this as our scratch area. 4x squared minus 6x. We can have, this can be expressed as 2 times 2 times x, right? And 6x we can express as a 2 times 3 times x. Okay? And since both of them has 1, 2, the common factors, so there's just 1, 2, and 1x, we can factor out 2x. And when we factor out 2x, what will be remain? 2x here, and here, the second term is 3. So this is 2x. Again, this the first two terms here, 2x times 2x plus 3. And how about this next two terms? So we can rewrite this negative 2x minus 3. Okay. So when we look about 2 and the 2 and 3, those are already prime, and we look about x, there's no common factors. And yeah, we can say that. We can say that. But however, we want to have 2x plus 3 as the common binomial for step 4. So in this case, we want to factor out negative 1. So negative 1, and when we factor out negative 1 or just negative, it's enough. But for us to see it clearly, we can factor out negative 1, and the signs will be positive here. So negative 1 times 2x plus 3. And this is what we want here. So we can write minus 1 times 2x plus 3 equals 0. And since both of them has common binomial of 2x plus 3, we can factor that out, 2x plus 3 and 2x minus 1. So 2x minus 3 times 2x minus 1 equals 0. So we factored this expression here. But now we want to determine the roots of the equation. So again, we just equated each factor to 0. So 2x plus 3 is equal to 0, right? Or 2x minus 1 equals 0. So we just first determine the value of x here in this first equation. 2x plus 3 is equal to 0. So we can have 2x is equal to negative 3. And divide both sides by 2. We can have x is equal to negative 3 over 2. And this is one root for our equation. Or we can also have 2x minus 1 is equal to 0. 2x is equal to 1. And divide both sides by 2. We can get x is equal to 1 half. So these two are the values for the roots for our quadratic equation. And you can substitute this. You can check by substituting these values, and this left-hand side over here must be equal to 0. Another example, 9x squared minus 6x plus 1 equals 0. So same idea. So our AC here, AC is equal to 9 times 1, which is 9. And B here is equal to negative 6. So what are the values, what are the factors of 9 that when we add them together, we can have negative 6. So we can see factors of 9. We can have 9 and 1. But when we add them together, that is 10. We can also have 3 and 3. But when we add them together, that is positive 6. But we want negative 6, right? But 9 also have factors negative 3 and negative 3. Okay, so negative 3 times negative 3 is positive 9. And when we add them together, it's negative 6. So we can express this minus 6x here as negative 3x minus 3x. So let's rewrite this quadratic equation. 9x squared minus 3x minus 3x plus 1 equals 0. So again, we can pair these first two terms here and this last two terms here. We can factor out 3x. And what will be left is 3x minus 1. Okay. And now, as you can see, let's just write here in our scratch area, minus 3x plus 1. We can just write it, right? Like this, plus minus 3x plus 1. However, we want to have the same binomial. So we can factor out negative 1 here. So we will get negative of 3x minus 1. Okay. So we can write minus 3x minus 1 equals 0. Since both of them has 3x minus 1, and there's another factor here, this is 3x, okay, minus 1. So we didn't write 1 anymore. It's not important. We omit when the numerical coefficient is 1, when it's multiplied to another number, we just omit 1 because it's the identity, multiplicative identity. Just we can have 3x minus 1 times 3x minus 1. Or since they are both 3x minus 1, we can rewrite this as 3x minus 1 quantity squared. And we have factored this quadratic equation. And now we want to determine the roots. We want to determine the roots. So we equate the factor 3x minus 1 to 0. So we equate it to 0. And we don't need to equate the other factor because it's also 3x minus 1. So we just need to equate 3x minus 1 is equal to 1. 3x minus 1 is equal to 0. So we will have 3x is equal to 1. And we have x is equal to 1/3. And this is the value. This is our only root for this quadratic equation. Let's try another example. When we have 16x squared minus 25. So again, we want to determine AC, and our AC here is 16 times negative 25. It's pretty huge, right? But for these types of equations, okay, when B is equal to 0 and there is subtraction, we can have a shortcut here where we can take the square root of this term and the square root of this term here, uh, and that is the sum and difference. So we can factor this out easily, okay, as 16, the square root of 16 is 4, square root of x squared is x, minus square root of 25 is just 5, and their sum and difference. So here is their difference, and their sum here for x plus 5 equals 0. So that is how we factor those when B is equal to 0. There's no need to determine AC. You can also try. You can also try, and that still works. But here, we don't need to do all of that. We can just factor it out for x minus 5 times 4x plus 5. And now we can dive straight into determining the roots. We can equate each factor here to 0. So 4x minus 5 is equal to 0, or 4x plus 5 equals 0. And now we will have 4x is equal to 5 and x is equal to 5 over 4, or 4x is equal to negative 5 and the other value for x is negative 5 over 4. And these two are the roots of our quadratic equation. So how about if we have 3x squared plus 8x plus 2? Okay. So 3x squared plus 8x plus 2 equals 0. So if we want to determine the roots, let's try again. Let's try again to see how to factor this by factoring. Factor. No, we try to determine the roots by factoring. So AC is equal to 6 and B is equal to 8. So if we determine the factors of 6, right? Factors of 6 are 6 and 1, 3 and 2, and the negative counterpart, negative 6 and negative 1, and negative 3 and negative 2. But as you can see, 6 plus 1 is 7, 3 plus 2 is 5, and obviously negative 6 plus negative 1 is negative 7, and negative 3 plus negative 2 is negative 5. So what happens here? There's no, the factors, none of the factor pairs have sum of 8. So that means this equation here is not factorable. Does that mean there is no root? No, it means there are no rational roots. There are no integer or fractional roots. But maybe there is an irrational root. There are irrational roots or complex roots, imaginary roots. So we will use other methods of determining the roots, such as completing the square or the quadratic formula, which we'll talk about in the next video.